Hi dears, this is Sister Lindsay from St. Joseph College of Arts and Science for Women. In this video, we are going to see about point estimation. Before going to see the point estimation, first we have to see what is estimators. Statisticians and researchers often use estimator functions to help them apply the mean average of a random sample to a more general population. This function is essential in scientific research, where the researchers want to understand how well a calculated average collected from a sample represents the actual population. Learning about the different types of estimators can help you better understand how they work in research and statistics. In this article, we explain what estimators are. Estimators are a concept in statistics that helps statisticians and researchers estimate the mean of a random sample when the mean of a random sample has a statistical significance. The statistician can reasonably assume that it's an accurate reflection of a population mean. This concept applies in scientific research, where the scientist tests a random sample of a larger population and generalizes their results to the total population. When scientists calculate the mean result of a random sample and determine that the result has statistical significance, it means the results aren't likely to come from random chance. For example, a pharmacologist testing a new migraine medication selects a random sample of 100 participants to try the medication. The participants self report how frequently they experience migraine symptoms over the course of a month. Then the researcher calculates the mean number of days the random sample having migraine symptoms. They find the sample experienced a mean of 10 days of symptoms. This number of represents the sample mean, also known as the estimator, and allows the researcher to estimate that a more general population is likely to experience 10 days of migraine symptoms per month while taking the medication. Next, we are going to see about point estimators. Point estimators are functions. These are used to find an appropriate value of a population parameter which is unknown. For the unknown variables, we have to find the estimators. For this, we are using this point estimators. For using the point estimator, we can find the more unknown value of the statistical values. For example, if we want to find the average age of the kindergarten students, we don't know and we doesn't know what is the particular age of the kindergarten students. For that, what we are using the statistical method of point estimators. So next, in this point estimator, there are three types of properties are there. First one is biased estimators. Second one is consistency estimators. And the third one is most efficient or unbiased estimators. Biased estimators, which are the point estimators, is defined as the difference between the expected value of the estimator and the value of the parameter being estimated. What is the difference between these two? We are finding using the biased estimators. And second one is consistency estimators. This consistency estimator tells us how close the value of the point estimator stays to the value of the parameter as it increases in size. If the size of the parameter increases, how the point estimator's value is staying close to the value of the parameter. That one we are using, finding out using this consistency estimators. Next, we are going to see most efficient or unbiased estimators. The most efficient point estimator is the one which the smallest variance of all the unbiased and consistency estimators. The variance measures the level of dispersion from the estimate. The variance, we can measure the variance, how the level of dispersion from the estimators. And the smallest variance should vary the least from one sample to other. And the next one, we are going to see what is unbiased estimators. Unbiased estimators, the mathematical expectation, that means an estimator Tn. Okay, Tn is the estimator that contain the number of observations from x1 to xn is said to be an unbiased estimator of gamma of theta. The gamma of if expectation of Tn is equal to gamma of theta for all theta belongs to the capital theta. The theta is the parameter space and this theta is the parameter and this theta is known as the parameter space. For this we'll going to see the example. If x1, x2, etc., xn is a random sample from a population, that is the normal population with the mean mu and the standard deviation with mean mu and standard deviation 1, we have to show that the t is equal to 1 by n summation xi squared, where I is equal to 1 to n is an unbiased estimator of mu squared plus 1. That means the expectation of t should be equal to this mu squared plus 1. For that, we ourselves have given expectation of xi equal to mu, that is in the n of mu comma 1, in this that mu is the expectation value and the 1 is the variance value, that only we are writing here. Expectation of xi equal to mu and variance of xi equal to 1, where the I is equal to 1 to etc. n. Now we have to find the xi squared. Since we are going to find xi squared here, we have to find the expectation value of xi squared. For expectation of xi squared, formula is variance of xi plus expectation of xi the whole squared. We know the value of variance of xi and values of expectation of xi. Variance of xi is equal to 1 and the expectation of xi equal to mu. So expectation of xi squared is mu squared. Therefore, expectation of xi squared is equal to 1 plus mu squared. Now we have to find the expectation of t, the estimator. So expectation of t is equal to expectation of 1 by n into summation xi squared. Since the 1 by n is constant, we will take out from the expectation using the formula expectation of cx equal to c into expectation of x. So we have taken out the constants 1 by n outside and the summation, then we can write expectation of summation equal to summation of expectation. So we have written here expectation of summation xi. Here we have written as summation of expectation xi. We already know the expectation of xi value is 1 plus mu squared. So we have written here. So here, since we don't have x here, the summation value will be 1 by n into x1 plus the mu squared. That numerator n and denominator n will be cancelled. Then we can get the value 1 plus mu squared. Hence, t is an unbiased. Since we got expectation of t is equal to 1 plus mu squared, we get t is an unbiased estimator of mu squared plus 1. This is the point estimator and this is the unbiased estimator. By this, we can find out how the unbiased estimator value. Okay, thank you.